We can imagine a very simple model of collusion amongst husbands to not hire each other's wives and thereby derive the benefit of being monopsonists in the local labor market, in particular vis-a-vis their wives, so that they hire their wives in essence at a much lower wage than they would if they were a competitive labor market for female labor in the village. So to show how we could model this fairly straightforwardly, this will be the first part, and we'll continue with a second part a little later. So this is part one. We start with a production function where the production function depends on capital and labor. The more labor that's hired, the higher production is, but at a diminishing rate. So we have a quadratic that looks like this. The more labor is hired, the more output you get. So output could be yield, which is a function of labor, but it's at a diminishing rate. And we assume that the capital that the men have is more than the capital that women have, and so men will be hiring and women will be supplying their labor. So the men's production function looks like that, and the women's production function might look like that. So this is for Km, and this is for Kf. So if that's the production function, we then think about what the profit maximization is for the men. So they're maximizing their production. And we just assume the value of production, the price is equal to 1 for simplicity. And then they have their cost of labor, so we subtract WLD from that. So putting in the time that they have, so we assume the men have an amount of time T that is their own labor that they're applying to production. So we get this expression, and we maximize with respect to how much labor they demand in a competitive labor market, and we get a labor demand curve. So labor demand depends on how much capital they have, as we might imagine. The more capital they have, the more labor they demand. It depends negatively on how much time the men themselves are supplying to work. So if T is bigger, then they don't need as much outside labor because labor has a diminishing marginal product. And then, of course, it depends on the wage. The higher the wage, the less labor is demanded. Now we go to the women who have a labor or supplying labor. They have the same problem, which is to choose how much labor to supply rather than to demand. So their production will be their time minus the labor that they're supplying. So this will be their production function, and then they gain wage revenue. So they earn a wage W for every unit of labor that they supply. So they choose how much labor to supply to maximize this function, the sum of their own production plus their outside labor income. So we take the derivative with respect to LS and set it equal to 0. We get this expression, just a straightforward maximization problem. Do a little bit of rearranging, and we get the woman's labor supply curve. If she has more time, of course, she supplies more labor. If the wage is higher, she supplies more labor. If her own productivity is higher, then she supplies less labor. So that's all pretty standard. We can then think of a competitive equilibrium. In a competitive equilibrium, the M, let's say, M husbands, the M men in the community, their demand for labor has to equal the supply of labor of the M wives. So we set the labor demand equal to the labor supply. The M's obviously cancel, and all this is just for simplification. And then we get labor demand has to be equal to labor supply. The 1/2s cancel. We do some rearranging, and we end up with the competitive wage, which, as we might expect, is going to be higher the greater the productivity of either the men or the women. So as their productivity goes up, they'd rather work on their own farms than in the labor market, and so the wage is going to be higher. And it depends negatively on how much time they have available. If they all have more time available, then the marginal product of extra labor is diminishing, and so the wage will be smaller. Now, if the husband is a monopsonist, so we imagine that there's a rule in this market that says that only husbands can be the buyers of their wife's labor, that nobody else can hire their wife. So a collusive equilibrium that men only hire each other's wives, men only hire their own wives, and no wife can work for any other man in the local labor market. Then the husband takes the wife's labor supply as given, and then this is a classic monopsony problem. The husband sets the wage in order to maximize profits. So the husband's production function is given by this, and how much they pay in wage income is given by that. They take the labor supply curve of the woman as given. They can't force the woman to work, so we assume. So they're a monopsonist, but not a slave owner, right? So we're sticking within the constraints in some sense of free choice, but a collusive equilibrium free choice. That we have here, where the men collusively agree not to hire each other's wives, and we're going to assume that they freely choose to not hire each other's wives. So this is the husband's maximization problem. For now, we'll not plug in the labor supply curve of the woman and leave it general, because we'll see that'll simplify things if we just leave it as general. So we take the derivative, and here's the derivative of the labor supply curve of the women. We'll just call it LS prime W. So we take the derivative of the first term, the derivative of the second term, and then the derivative of the third term. Note that the derivative of the third term is two terms. So first, the derivative of this term with respect to W, well, we have the negative W here multiplied by the LSW, and then we have the derivative of the LSW multiplied by the negative W. So that's why we have two terms down here. So we take the derivative, and now we note that LS prime W is the derivative of the woman's labor supply curve, but that's really simple. It turns out to just be a half. So we can substitute that back in here and here and here in the original equation, which gives us something much simpler. Now we do some multiplication and some rearrangement. And a little bit more rearrangement and a little bit more rearrangement, and finally we get the monopsony wage of the husband, which is rising in his own productivity and the wife's productivity. If he's more productive, he wants to pay her more so that she comes and works more. If she's more productive, he has to pay her more to get more of her labor, and it's declining in the amount of time that the people have. So what we might ask now, we've calculated the competitive wage and the monopsony wage. For the husband, is the profits in the competitive situation greater than the profits in the monopsony situation, or the reverse, the profits in the monopsony situation greater than the profits in the competitive situation? We'll continue in part 2.